Okay.
Students, you'll need your 7.4 out, please. And remember that you always have to have a
oh, they thought it was good. Yeah.
Naomi? What?
Oh, it's why not? Yeah.
Here comes me.
Oh, you.
Chapter 7.4.
Oh, dude, no. Oh, man, I'm what was yesterday? 127 or something? 7.4? That's pretty solid.
All right. Were there any questions left over from yesterday's energy use inventory? When we talk about electricity use and gas use and stuff, anything like that? No? You're going to need your 7.3. talk about this when we talk about fracking?
Yes. Yeah.
Did we talk about why natural gas is a new fuel?
Yeah.
Because we haven't really had the technology to handle it in the past. Yeah, and it's actually all the like compression, the filtration, the separation stuff. Did we talk about why natural gas is so clean once you've burned it? Yeah. The molecule can't hold other pollutants. It weighs it down too much and it stops being a gas. So if that's behind us, I guess we're moving on to study goal number 21. This whole fracking thing is starting to look shady, but people are excited. And now, where else can we get it? Well, one place we can get it is wherever you find coal. Remember that natural gas, coal, and petroleum are always mixed together to some degree. If you have any fossil fuel, it's going to have a few little pieces of short carbon chains. Those are going to be the methane. So in a petroleum deposit, you'll get some methane. In a coal deposit, you'll get some methane. In a peat deposit, you'll get some methane. Pretty much any place that you've made some type of a carbon chain, you'll have some type of methane. So as I think everybody knows, the United States has a lot of coal. Did you guys know that?
Yeah.
We are one of the world's biggest coal producers.
Yeah.
Yeah, we have about a quarter of the planet's coal. So because we've got so much coal, we've got a lot of natural gas. That's the good news. We have a lot of it. It's easy to get. Mechanically speaking, this is really simple. The bad news is, really the best way to get coal bed methane is to use water to squeeze out the gas, the same way that water squeezes out petroleum offshore. In a coal bed, you kind of have to push the gas out by pushing water through the coal, like this. You squeeze in the water, and then the gas bubbles out. And that's both the good news and the bad news. Easy to get, but what are you going to do with all of that water that's hosed off a bunch of coal? Realistically, the only commercial answer is to make these giant artificial lakes of coal slurry, which are a hazard every way you think about it. They're nasty surface water. It's totally terrible. Like hydrocarbons mixed with water, that's about as toxic as you can make something. You know. As far as volume of pollution, this is one of the most toxic by volume substances in the United States. We make these giant lakes of coal slurry. Then we just hope the water will evaporate out so that the slurry gets thicker and thicker and thicker and thicker. And then we just kind of like push it into the ground and bury it. Yeah, I mean, it sounds great. No problem with that. I see no problem with that. What groundwater? The funny thing is, like, it's a mechanically simple answer, and it's a readily available fuel, and every time somebody drops their guard, some other person will go, oh, okay, I got something to sell, don't worry about what's behind the fence. I got methane for sale. We've made a lot of this in the United States, and the flip side is we've made this, I'm not exaggerating, like trillions of gallons of pollution. Like with a T, like it's many trillions of gallons. There's another place we can get it too. There's a bunch of methane locked up in ice. I got to try a little bit of something that's sort of like chemistry. You guys might remember that water. Yeah.
Is this like only at the bottom of the ocean where it's super pressurized, or is there there's nothing trapped in like the air bubbles, ice cubes?
They're not usually ice bubbles. So I'll explain it to you. You guys might remember that water looks like this, like the Mickey Mouse thing with the little hydrogens and the oxygen. But when water goes from liquid to gas, it expands. I don't know if you guys remember that. Yeah. So you've got the water molecule like this, and another water molecule like this. And when they're liquid, they can move past each other. They don't really touch, but they can kind of move around each other. When they go to freeze, because water is polar, so it's slightly positive over here and slightly negative over here. Because of that polarity, they have to kind of like line up in this funny way to freeze. And so the other water will have to come over here to freeze. And so to get into that crystalline structure, this crystalline structure, water has to expand. It needs more volume. That's why ice cubes float. They stick out of the water a little bit. It's the same number of molecules, but in the ice, they're separated by more empty space, so they kind of push out of the water. Displacement is not equal to the volume. On the other hand, methane is a pretty tight little molecule. Hydrogens are small and carbon is relatively small. I don't know why this is, but methane is like a really snug fit. Over here in water, hydrogen doesn't like oxygen that much. They're just sharing electrons. But hydrogen and carbon, I don't know what this is. I'm sure a good chemist could explain why. For some reason, the methane molecule, the pieces are just really close together. So if this is the size of water, this is the size of methane. Methane is just snug, it's tight. So check this out. If you have methane when ice is forming, the water will expand into this structure. The funny thing about methane is, it'll get trapped. It's like in a little jail. It fits in there. Everybody says bubbles in ice. But remember that a bubble of methane is like 1 trillion molecules. Right. So it's not a bubble. The ice looks like ice. When you look at an ice cube, you don't see water molecules, right? The same way, you won't see the methane molecules. They're just not bubbles, like at the molecular level, in all those water molecules, in the little spaces in the crystalline lattice. You squeeze in methane. Each of these would have a little methane in it. So, check this out. You can light ice on fire.
Nice.
Yeah, that's no joke. Like, that's really... You can see that crystalline lattice with the little methane in the middle. Remember I told you how you can have that little tiny methane trapped in the lattice? Yeah.
So it's not like a bubble of methane in the ice.
Right.
Okay.
It's like
it's chemically in the ice.
A gajillion orders of magnitude smaller than bubbles.
Okay.
Yeah.
Would the like cold water stuff extracted without being flammable?
Yeah.
So we could burn it.
If you didn't mind the pollution, probably.
What we're saying,
But it's not polluting anyway.
Oh, yeah, so instead of making a lake, yeah, I mean, now you've got air pollution instead of water pollution, but yeah.
Well, you might as well have air pollution instead of water pollution.